Okay, this is the first video for the Object Manipulation Unit Notes. Learning goals for this unit, I want you to be able to discuss the different types of manipulators, discuss different types of accumulators, and identify characteristics of a successful accumulator. All right, so getting started here, all robots are designed with a purpose. The manipulator is how the robot's going to interact with its environment to fulfill that design purpose. So, some types of manipulators. We can basically break them down into three categories. We got plows, scoops, and grabbers. So the plow, pretty simple design. What it does is it applies a force on the object, and it doesn't pick it up obviously, but it pushes the objects around. This is the simplest design. Um, I would say build it as a last resort, especially for robotics competition, but it's something to think about. All right, the next type, the scoops. This is designed to lift something up. So this is going to apply a single force underneath the object to elevate it. There are different types. Um, this one is just a simple a mechanism that lifts it up. You would also want to use, if you were to design this, you'd probably want to use a linkage system also to keep the platform um, level. If you look at this design here, as this rotates up, I think we can see that the ball is going to slide off of it. But if you had a linkage system, something that looks like this, as this were to elevate, this would keep the platform level. All right, third category, the grabbers or the friction grabbers. Uh, with this, we're going to use friction, so that means there has to be a normal force. Remember that a normal force is always perpendicular to the surface and also perpendicular to the friction. So if we take a look at this design right here, we can see that we have our force due to gravity and that there must be a force due to friction. And then if we take a look at a top view, here the friction's coming out at us, the gravity is into the board. We have the applied force, so we got this normal force acting on it. Actually, I think got the arrows wrong. Should be the other way. There we go. So there's our normal force. So we see the normal force is being supplied by the applied force. In this design, there's going to be a spring in this mechanism, or the motor can supply the applied force, which gives us the normal force, which gives us friction. And remember that friction is equal to the coefficient of friction times the normal force. So when we make the normal force stronger, the friction force becomes stronger as well. So when designing one of these, you want to make sure that you have some sort of traction pad. The traction pad determines the coefficient. The stickier the traction pad, the larger the coefficient of friction will be. Now this type of design, it's very nice, but you have to be very precise when you operate it. So here's some other designs. This right here is the pinching claw. And, you know, with this, with some minor adjustments, we can configure it to accommodate a wide variety of objects. Something else, the traction pad itself, you can get creative with the traction pad. Here, the traction pad is a series of flexible rubber fingers. And this really increases the surface area so that you can have a lot of friction. Something else that you might want to consider, help your motor out with some passive assistance. Use some rubber bands to help secure the object. And one of the reasons for this, a good design does not require the motor to be on continuously. So, for example, this design right here, which uses the rubber band. The claw itself should have some sort of elastic give to it. That way you can have a larger normal force. Another design that you might consider is using a worm gear to help operate it. It'll be a little slower, but worm gears, remember, you can't backfeed a worm gear. Once this is closed, uh, this claw will not be able to open again against the worm gear. So the worm gear acts as a nice brake. Once you set it, it'll stay at that position. All right, now starting to kind of putting these together. Um, this right here would be an example of a scoop and a grabber, the top jaw grabber. And basically what this is we have a stationary lower jaw with an actuated top jaw. So we can see that we have a motor here that powers this actuated top jaw. So what happens is the bottom one is going to provide the normal force while the top one provides the friction grab. So this is a nice design, but you want to be careful. They can be a little finicky and they can be a little slow. They can also be weak. If you want to design something like this, you want to make sure you over-engineer it and make it as strong as you can. Another type is the rolling claw. So here we see that we have some sort of stationary elastic part, and as the wheel turns, it's going to force the ball into that holder. What's nice about these is that they're fast. So if you need to gather a lot of parts very quickly, these ones are really quick. Down here's another example of this using a rubber band. One thing that's characteristic about these is that there must be some elastic give. And the purpose of that is so that you only have to use one motor. If you're doing this design, you don't have to worry about using a lot of motors. All right, this concludes video 1.